All right, in our second example, an Astros player hits a baseball with an upward velocity of 46 feet per second, and the ball's height h in feet after t seconds is given by the function h of t is equal to negative 16t squared plus 46t plus 6. In part A, we want to find the time t when the baseball will be at its maximum height. Okay. The first thing I'm going to do before we try to solve this is I'm going to kind of illustrate what's going on here. Okay. One of the biggest differences between this problem and example 1, which was the fence problem, is that we're actually given the quadratic function here. H of t is equal to negative 16t squared plus 46t plus 6. In the fence problem, you actually had to build the quadratic function before you could use it, but here it's just given to you for you to use. Okay, let's draw a little sketch of what's going on. Okay, basically you've got this Astros player. He is hitting the baseball with his bat, and this function, what it's doing, it's drawing out the path of the baseball. That's how you can think of this. All right, so let me put the axes on here. All right, so here's what we got. Notice here for this function, we are not using x, we're using t here. So keep that in mind. So this is going to be the t-axis instead of the x-axis. If you read the problem again, it talks about t seconds. So t is measuring time in seconds. And then the way this function works is you plug in a time value, and the output is going to be the height of the baseball in feet above the ground at that time. Okay, so the y-axis is representing height, which is h. And again, that is also, or that's going to be measured in feet. Okay, and like I said, you can clearly see this is going to be a parabola. This is a quadratic equation or function. The highest power of t in the whole thing is 2. And also the number in front of t squared is negative. So this is going to be a parabola that opens downward. Okay. You can plug this guy into your calculator to see what it looks like. And if you do that, you're going to get something, and I'm just drawing a rough sketch. You're going to get a parabola that looks like this. Okay. Notice that the parabola does not start at the origin. And you can think about that. If you were playing baseball and you were up to bat and you went to bat and you hit the ball is not leaving from the ground. It's leaving from the point of contact with the bat. So that's why the graph looks like this, where you don't start at the origin. All right, so again, what this is representing, this is basically the path of the baseball. Okay, so this is where the baseball is hit. It goes up, it reaches its maximum height, and then it comes back and hits the ground at some point if it's not caught. Okay. All right, so in part A, we want to find the time t when the baseball will be at its maximum height. Okay. Since this parabola opens downward, it's going to have a maximum. All right. So in part A, it's asking for the time at which the baseball will be at its maximum height. Okay, so remember, when you're dealing with the vertex has 2 coordinates. It's going to have a t coordinate here, a time coordinate, and then it's going to have the vertical component, which is the height. Okay, and you're looking for the time value when it reaches its maximum height. So whatever this time is right here. Okay, so remember your vertex formula. The x value of the vertex is going to be negative b over 2a. Okay, remember x is t here. Okay, so all you have to do to answer part A is plug into negative b over 2a. Okay, all right, if you look at your quadratic function here, the a value here is negative 16 and the b value is positive 46. So just plug into those guys. Okay, so this negative is part of the formula. Okay, b is positive 46. we're going to be dividing that by 2 times a, which is negative 16. Okay, that's going to give us negative 46 over negative 32. And if I plug that into my calculator, let me see what that gives me. It's going to give me 1.4375. Okay, that's a time value. And remember, that's measured in seconds. Okay, so that is when this ball is going to reach its maximum height. Okay, all right, I'm even going to go back to the little sketch over here. Okay, and I know I'm going to write down this ordered pair. I know the t coordinate so far. That's 1.4375. Okay. All right, in part B, it wants us to find the maximum height the baseball will reach. Well, still we're referring to the vertex. Okay, we just need the other coordinate. We need the y coordinate or the h coordinate. Okay, we know this baseball reaches its maximum height at this time value, 1.4375 seconds. So all we need to do is plug that time value into the original function to get the height at that time. All right, so to find the maximum height, we're going to plug 1.4375 into the original equation. Okay, so we're going to get negative 16 times 1.4375 squared plus 46 times 1.4375 plus 6. Okay, and then you just need to plug this guy into the calculator. Let's see if I can do this. Yay. All right, trying to make sure it's not too dark. Here, I'll go ahead and just plug it in. All right, so we're going to get negative 16 times 1.4375 squared plus 46 times 1.4375 plus 6. Okay, and that's what we're going to get. Okay, so let me write this down. All right, so that's going to be your maximum height. And remember, if you go back and look, height is measured in feet. Okay, so the maximum height is going to be 39.0625 feet. Okay, and now I can finish labeling this coordinate, which is not necessary, but I'm just trying to make my picture complete. Okay, so what we know from parts A and B is that the baseball reaches its maximum height of 39.0625 feet at 1.4375 seconds. Okay. In part C, it asks, how long will it take the baseball to reach the ground? Okay. Well, if you go back to the sketch, okay, we know that, this is where the baseball leaves the bat. It reaches its maximum height at this time, okay, and then it goes back down and hits the ground, okay. Your first thought might be to double the time. You cannot do that here, okay, because you do not have the entire parabola, okay. So the best way to do we didn't start at the origin is what I'm trying to say. Because we didn't start at the origin, you can't just double the time, okay. So what you're going to do here, okay, this is where the baseball is going to return to the ground. Okay, this is where it's going to hit the ground. And at this point, the height above the ground is 0. Okay, it's on the ground. So the height is 0. So what we're going to do is we're going to set our height equation equal to 0. And we're going to solve this. Okay, so this is a quadratic equation. It's got an equal sign. Highest power of t is 2. Quadratic equation. Okay, your options for quadratic equation are always factoring and quadratic formula. Okay, these numbers are kind of big. Okay, so it might be a little difficult to factor. So I'm going to jump straight to the quadratic formula. Okay, we already know A and B up here. We identified those already. C is the constant 6, and that's what we will plug into the quadratic formula. So remember, the quadratic formula is, it's going to be t equals, here you're solving for t, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to go ahead and plug in for that, and that's going to give us our time values when the baseball is on the ground. All right, so let's plug in. We're going to get negative b, so negative 46 plus or minus the square root of b squared, so 46 squared, minus 4 times a, which is negative 16, times c, which is 6. Everything is divided by 2a. All right, let's simplify. Remember, I tell you time and time again, always start underneath the square root and see what's there. Okay, so let's get our calculator here. Whoops. All right, so underneath the square root, we have 46 squared minus 4 times negative 16 times 6. Okay, so we have 2,500 underneath the square root. Okay, so this is going to give us negative 46 plus or minus the square root of 2,500 all over negative 32. All right, so then if you actually calculated the square root of 2,500, you're going to see that that's 50. Okay, so this turns into negative 46 plus or minus 50 over negative 32. Okay, so now we can write out our solutions. There's actually 2 time values that you should get here, one for the plus, one for the minus. So the first time value is going to be negative 46 plus 50 divided by negative 32. And then the other time value is going to be negative 46 minus 50 over negative 32. And I'm going to pop both of these in the calculator to see what I get. So the first one, like I said, negative 46 plus 50 divided by negative 32. Okay, this is going to give us negative 0.125. And then the second option, negative 46 minus 50 divided by negative 32, is going to give us positive 3. Okay, and remember, these are both time values. Okay, so they should be measured in seconds. Okay, so if you notice, we got 2 time values and one of them is negative. Okay, that does not make sense. Negative time does not make sense. Okay, so we're going to have to exclude this one. Okay, going back to the picture, okay, remember this is where time equals 0. This is where the bat hit the ball. So this negative time value is over here. That's what that's calculating. That's not what we want. We want the other time value. Okay, so right here, that's where the ball comes down to the ground. That is 3 seconds. Okay, so that is the answer to the question. It takes 3 seconds for the ball to reach the ground. Okay, and notice you do not get that answer by doubling this time value. If you multiply this guy by 2, you don't get 3. Okay, the correct way to do part C is to take the height function and set it equal to 0.